There might be a plus, so I'm going to do something with plus, but it's actually going in a linear direction from left to right, first doing the space stuff, then doing the plus or minus stuff, then doing the digit stuff. So they're completely disconnected. And this is basically the best way you can approach problems. It's by cutting it into completely standalone pieces and formulating or using a pattern for each of the pieces and fill in the gaps of the pattern, which is what we're now going to do for the if statement, depending on the actual problem context. So we don't have to care in this case about something that starts with spaces. And if we are in step number 3, we don't even need to care about the sign. Now our problem is just looking at normal numbers. And so the problem becomes less and less complex, and the task itself gets a bit easier and easier depending on the circumstances. So the next step might be, okay, if it's a plus 42 is exactly the same as 42, so we're basically going to do nothing. The only thing is, part number 3, what does it expect? Just as we checked for the main function what it expects, now what does part number 3 expect? Something like this, or maybe something like that. No spaces, no sign. We already took care about the spaces here, we already took care about the sign here. So, right now the current character is a plus. In order to remove the plus, what should we do? Skip. How do we skip?
String plus plus.
Right. Done. Now the minus is a bit more tricky because minus 42 is of course not equal to 42. Big math, I know. Like this is complicated stuff. Okay, so still our current character is a minus, and this doesn't expect a minus. Sounds similar to the previous case, right? So skipping is already something that's logical. Anything else that might make sense? Well, yes, we need something more, because we somehow need to tell this part that if you read the number and you've got the number, in the end, please put a minus there. Like, please multiply it by -1 or something so that the actual number returned is negative. So this part doesn't only need to take the string, but also maybe some kind of value, either 0 or 1, or maybe some kind of other value that tells it whether it's positive or negative. So that if we really have the string -32, that we can have like a string with the 32 and some kind of data that tells, okay, it's positive or negative. And for that, we need a variable. So, in sign, and this is a variable that's either 1 or -1, depending on whether it's positive or negative. You might have already encountered that before. If not, this might be new. But technically what this is saying is, by default, it's 1, otherwise it's -1, and if we have the 32 in here, we just multiply it with the sign so that 32 times 1, which is the default, gives us 32. But in here, we just say sign equals -1. And once we get here, once we have the minus, suddenly this one gets swapped to -1, which is exactly this data that we need, so that in the end we can just multiply this value by the -1. Make sense to you, or is there something still unclear? Okay. And the last step is doing the digit stuff. And this is something I'd like to leave to you. It's similar to that. You look at what you have, you look at, oh, we can have not only 1, but 2 or even more digits. So what do I do? Sounds like a while statement, right? And now you already have a clue on how to continue. Like again, we had multiple spaces, and once you hear multiples, so a varying length could be 0, 1, or 2, it's most often some kind of while-related block of code. And so, the first hint I can give you is while. And what else to fill in, again, is mostly done by just looking at what you have, where you need to go, and then by just looking at the problem itself, identifying what kind of pattern could occur at this location. Okay, so this was a rough overview about how to approach the atoy function. Of course, if you see it done like this, and then you're sitting at the screen and you try to reproduce it again, of course this might be too much. Like you see this and then, okay, I can understand that, but in the end, well, of course. So I'm going to give you a short list of patterns that you might find useful. And then your task is to look at your code that you've written, look at code that other people have written, identify these patterns, find them again, find the variations, and look for the right pattern to put into each place here. Okay. Like this is the second part of the lecture, and the last part will be about pointers and stuff. Can I clear this off, or is somebody still interested in? Okay. And again, don't be afraid if you're confused by the amount of concepts now coming up. This is normal. So the same thing happened to me when I started out C. So I think it took me about 2 or 3 years to learn C to the fullest. And even then, I was still surprised by the way some people approach problems. So there's always something new to learn, and don't be afraid if something doesn't work the way you intended it to be in the first or second iteration of your code. Okay. There are a few different classes of patterns. First of the first thing is the initialization patterns. So you need them when you have variables or data that is not initialized. For example, you write something like int x. And of course, if you now tell the system to print x to you, what is this going to give you? Has anybody tried this out before?
It should give the value that is stored in x, but we never declared the value.
Yeah, I mean, we have declared it, but we haven't defined what.
Garbage value?
A garbage value, that's right. So, since we have never set x equals 42 again, the system doesn't know what's in here. We've just told it, okay, there's a place called x, but we've never told it what to put in here. And the computer is quite stupid. So the computer is really dumb and it doesn't know what to put in here. It could assume that, well, it's an integer, so it's numbers, so 0 might be the thing you need, and some systems might do it, but there's no guarantee that this will happen. So this number is basically random. Not completely random, it's not like flipping a coin 50-50 random. In most cases it's 0, but in about 10% of the cases it's not 0, it's some random value. And this is bad, because if you forget to put a value inside of a variable, and you think, oh, it's gonna be 0, in 90% you're right, in 10% you're not. And if you were to write some kind of code that controls an airplane that crashes in 10% of its cases is not that good. And I suggest that we as programmers have some kind of responsibility that our code runs well. Most people know some kind of error message that comes up. I think most of us have seen something like this. And this is quite annoying. And stuff like that usually happens when people forget to initialize their variables. They think, okay, this value is somewhere in here, and it's all right, this is going to be 0, and it's not. And in these cases, these errors occur. And of course, apart from the fact that Moulinet or even your evaluators will not grade this, or not grade this well, I think it might be in our best interest if we were, for example, to write our libft, to just refrain from these cases where it tends to work, but sometimes it might not. So initialization patterns are actually quite useful, and I think they're necessary in order to write code that really runs the way you expect it. So there are two patterns here. The first one is the variable declaration. Pattern, and this is the variable initialization pattern. And you're going to see these mostly at the top of functions. So you have a function with some kind of type, some parameters, and this pattern is going to be the first thing you'll see. Even the norm will tell you to put the declaration pattern right in front. So the declaration pattern will always be the first thing in your function. And the second thing should always, or in most cases, be the initialization. If you see code that doesn't have the initialization pattern right after the declaration pattern, this might be a case of error. So whenever you try to pinpoint a bug in your code, it's mostly because you forgot the initialization pattern right after the declaration. So we have the... And this basically marks the first class of patterns. The initialization patterns being the variable declaration and the initialization. Declaration is necessary if you need variables. Initialization is something that you tend to forget quite easily. So always make sure that initialization patterns are in your code. And there are multiple variations. If you have, for example, int x, the corresponding pattern will be x equals 0. Because the int is a number, and 0 is the most basic number, especially in computer programming. If you have something that looks like char str, the corresponding initialization will be str equals either null, which is pointing to nothing, or str equals to some kind of string. This is the only way you should initialize something that looks like this. A char star should only be initialized like this or like that. You could also do something like, well, str equals str_dub or some kind of other function, but technically the output of this function should also be a char pointer. So when you look at str_dub, it's char str_dub, which also takes something else, and this char should match this char. So whenever you put something into str, it should